Now that we've discussed how to simplify rational expressions, we're ready to start solving rational equations. Rational expressions and rational equations look pretty similar, except in the case of rational equations, you have this equal sign. You have something on either side of the equal sign. And the goal with rational equations now is to solve for the variable, in this case x. Before we get to solving this equation, I'd like to recall what we did when we were solving equations that had fractions in them. If you'll remember, we made our lives a little bit easier by clearing the fractions or getting rid of all the fractions before we started solving. What we do is we multiply every single term in this equation by a number that's going to get rid of all of the denominators. You may have called this number the least common denominator. In this case, it's going to be 6. And you'll see why here. If we multiply every single term by 6, if it helps, you can think of 6 as 6 over 1. In the first term, the 6's cancel and you're just left with an x. In the second term, we're left with 6 over 3, which is just 2. And on the right side of the equation, we're left with 6 over 2, which is just 3. And now you'll see that by multiplying by this least common denominator of 6, we've gotten rid of all of our denominators, and we're left with a much simpler equation to solve. In this case, of course, we subtract 2 from both sides, and we get x equals 1. Now, this is the exact approach that we're going to take to solve rational equations. We're going to find the least common denominator, and we're going to multiply every single term in the equation by that least common denominator to get rid of all of our fractions and leave a much simpler equation. Okay, I think we're ready to try this thing out. In order to most easily find your LCD, you're going to want to factor first. The only thing we can factor here is this difference of squares. And now we're looking for the expression that's going to get rid of all of our denominators if we multiply it by each term. The expression with the smallest number of terms in it that's going to allow us to clear all of our denominators is x plus 2, x minus 2. Now, I'm going to multiply this through the numerator of every single term. If it helps you, you can think of each one of these terms as over 1. And you'll notice now that we have a lot of canceling to do. We have terms in the numerator and denominator that are exactly the same on every single one of these. Most importantly, you'll notice that every denominator on every single term cancels. Now that it's looking a little bit messy, let's clean this up and see what we're left with. On the left side of the equation, we're just left with 8 over 1. In this term right here, we're left with an x minus 2 times x in the numerator. And we have minus x plus 2 times 3. What we're left with at this point is an equation that we can hopefully solve. Let's see. I'm going to distribute the x through the parentheses and the 3 through the parentheses. Don't forget that this negative distributes through the parentheses as well. Now, our only technique for solving equations like this at this point is to move everything to one side of the equation and hope that it factors. So I'm going to combine like terms. The minus 2x and the minus 3x gives us negative 5x. And if I subtract 8 from both sides, I'll get minus 14, leaving on the left side a 0. Fortunately, we're good at factoring, and the right-hand side of this equation factors into an x minus 7, x plus 2. We split this up into two pieces. First piece is going to give us x equals 7, and the second piece is going to give us x equals negative 2. You'll notice that I've called these possible answers, because when we're solving rational equations, sometimes in this last step we get answers that don't work out. To be more specific, if you get an answer in your last step that's going to make any of your denominators 0 in the very first equation, that makes your equation undefined, so it's actually not a solution. So the fancy word we use to describe this answer that we got that doesn't turn out to actually be a solution is extraneous solution. It's not actually a solution to the original problem. The only solution that we found to the original equation was x equals 7. And in a perfect world, it would make sense to check your answer by plugging x equals 7 all the way back in up here in the original equation. I'm just going to trust that we did the math correctly and say the solution is x equals 7. All right, let's do one more of those in this video, and then we will practice in class. The first step is going to be to factor so that we can most easily find our least common denominator. The denominator on the left-hand side factors into x plus 2, x plus 6, which conveniently appear in the right-hand side as well. So the term with the fewest number of factors in it that we can multiply this whole equation by to get rid of denominators is just going to be x plus 2, x plus 6. And if we multiply every single term in our equation by that LCD, you'll see that all of your denominators are going to cancel out. Let's see what we're left with. On the left side, we just have x minus 10. On the right side, we have this x plus 6 times 3 and this x plus 2 times 4. I'm going to distribute the 3 and the 4 through the parentheses. I'm going to combine like term. Now, this just looks like an old linear equation. That means all of our x's are just to the first power. So what we can do is get all of our x's on one side of the equation. That means subtract x from both sides. We can get everything else on the other side of the equation. That means subtract 26. And now to isolate x, we just divide by 6. So the only possible solution we get is x equals negative 6. Unfortunately, you'll notice that if you plug this back into the original equation, that's going to make this denominator 0, and it will also make this denominator 0 here. So again, that's what we call an extraneous solution. It's not actually a solution to the original equation. When our only possible solutions turn out to be extraneous solutions, well, that just means we don't have any solutions. That's somehow a little bit unsatisfying, but that's the answer. Okay, I'll see you all next time.